Dear students, today I am going to explain about version space and candidate elimination algorithm. In the last class we have discussed about finders algorithm. Finders algorithm means already we know finding maximally specific hypothesis. Okay, so in that we are going to find the maximally specific hypothesis. We will start with specific hypothesis and will move towards a general hypothesis. And here in finders we are going to consider only positive training examples. Negative training examples we won't consider in finders algorithm. That is the main drawback of finders, considering only positive training examples, no negative training examples. And another thing is there will move from only the specific to general. General to specific is not possible in finders algorithm. Okay, so these things, these problems are overcome by the candidate elimination algorithm. First we will see version space, then we will move to the candidate elimination algorithm. First, version space and candidate elimination algorithm. The key idea of candidate elimination algorithm is to output the description of the set of all hypotheses consistent with the training examples representation. Okay, all hypotheses should be consistent. That consistent is, it is very important one, that with the training examples representation. So how we can define this means a hypothesis H. Always you get to represent the hypothesis, we are going to use H is consistent with, how we can tell, with the consistent can be defined with a set of training examples D. Okay, capital D is set of training examples if and only if H of x is equal to C of x. Okay, C of x for each example x comma C of x. X we know that is a instance. X comma C of x in D. Okay, consistent H comma D. H already we know it is a, H is a hypothesis. D is a training examples, that is equal to for all x comma C of x, that is a subset of D, then H of x is equal to C of x. So the first we should know the difference between consistent and satisfies. There is but generally we will see consistent satisfies, we can tell same, but there is a major difference between consistent and satisfies. Okay, that means an example x is said to satisfy hypothesis H when H of x is equal to 1. Okay, regardless of whether x is a positive or negative negative example. Okay, H of x is equal to 1 means that x is said to satisfy hypothesis H. Okay, that is S. H of x is a Boolean function, no, it returns the value true. Then if example x is said to consistent with hypothesis H if H of x is equal to C of x. Okay, this is the difference between satisfies and consistent. So first we should define version space. Okay, so representation of set of all hypotheses which are consistent with D. Okay, so D we know that's a training examples. Hypothesis normally we are going to call with H. Okay, the version space, how we are going to define means V, version space V, yes, H comma D. H is the hypothesis, D is the training examples. With respect to hypothesis H and training example D is the subset of hypothesis from H consistent with the training examples in D. That's the reason we are defining VS H comma D version space with respect to hypothesis H and training example D is equal to H belongs to H, capital H. Okay, it's a subset of the entire hypothesis such that consistent of H comma D. Okay, version space, we know that hypothesis space is H and that examples, training examples are called as D. Then version space is defined as VS of H comma D. In the suffix you should give H comma D. Then the list then elimination algorithm. First we'll see. Okay, eliminate algorithm. List then eliminate algorithm. So this algorithm first initializes the version space. That first step is initialize the version space. That version space will contain all hypotheses in H. Okay, and then eliminates any hypothesis which is inconsistent with the training example. Okay, initially we are going to take all the hypotheses in that we initialize the version space with all the hypotheses, and then next we are going to eliminate the hypothesis which will be found as inconsistent with the training examples. Okay, that is the list then eliminate algorithm. After seeing that list training examples, we are going to eliminate the hypothesis space. Okay, so version space, the list then eliminate algorithm is the version space C, a list containing every hypothesis in H. For each training example x comma C of x, remove from version space any hypothesis H for which H of x is equal to C of x means it is consistent. H of x is equal to not equal to C of x means it is inconsistent. Inconsistent means that will be eliminated. Output the list of hypotheses in version space. Okay, understood now? Initially it will be H will be initialized version space contains entire hypothesis. Then after reading the training examples, it will check the condition H of x is equal to C of x. If it is equal means it is consistent, no issue. If it is not equal, that will be eliminated, removed from the version space, and remaining space should be taken for the next example. Okay, so the more compact representation for version space is represented by its most general and least general members. Okay, then these members from general and specific boundary sets that delimit the version space within the partially ordered hypothesis space. Okay, first it will be the complete hypothesis space when after the D step it will move to the partially ordered hypothesis space. Okay, this is the example we have taken. This example, this is the same that enjoy sport game example. 6 attributes and there is a target function, true or false. There is a boolean function. So here we will take first is sunny, warm, normal. There is sunny. Yeah, okay, when that person can go and play the game means sky should be sunny and the air temperature should be warm. Cold means can't play. And then next is this can be humidity can be, it may be normal or high. That's why this is general question mark. And then wind should be strong and water may be warm or cool. That's a question mark. Forecast may be same or change. That is a question mark. Okay, so again we are going to divide this. We are going to get sunny and then next two things sunny. Then sunny will come. Next is warm. Warm is there. Then it may be warm or cold. There is a question mark. Then next is also question mark. Strong. This is the thing. So that as it is we are going to take sunny. The second one only we are changing. Here sunny, warm will be there. Strong we are making into more general. Next is this two is question mark. Sunny with first attribute we are making into more general and other attributes as it is. Okay, so now we'll join these two. We are going to get this one sunny, then question mark, warm, question mark, question mark, question mark, question mark, strong, question mark, question mark, question mark, question mark, question mark, question mark. Okay, then we'll combine these two, join these two. We are going to find out warm, warm, warm means sunny, question mark, warm, warm. Then other things are general, question mark. There is a general hypothesis. Okay, so this is the thing. Based on that thing, it will be eliminated. Then finally, we are going to get the consistent hypothesis. Okay, this only it will be taken in the version space. That is list and elimination algorithm. Okay, I think you understood what is the consistent and satisfies and how it will be used for finding the target function in this. We have taken the example as enjoy sport game. Okay, thank you.